Hello and welcome to the Sustainable Power Generation course. This will be a small series of lectures on steam cycles, the most fundamental, the most important knowledge that you need to know, you need to remember about the concept of steam cycles. You may have such knowledge previously, and in such case, this lecture will serve as a refreshment to what you've learned before. We will cut this lecture in 3 sections. First, we'll focus on some historical notes and interesting points for the development of steam cycles to our modern age. Then we will continue with other important issues. Ancient history, well, talking about modern technology, it's always important to start with some historical notes. And talking about steam cycles, you can easily imagine that actually humans understood that there is lots of power contained in the steam since long ago, as long as there are humans on this planet. Boiling water was one of the primary objects of sustaining life, but producing a device that was using the power of steam was probably a bit of more difficult task. And now imagine again that even if it's easy to understand the whole concept of steam cycles, it's actually very difficult to manufacture a device, especially in the old days when there were no good materials for that. And even up to this point, materials and technology are the governing factors for producing a better and more efficient steam cycle. The first documented, at least documented device that was running on steam, even if being only a toy, was a kind of a rotating sphere around year 60 before Christ in the Roman Egypt, which was, well, you can imagine how it works. Water boiling, rising up through these brass pipes into a brass sphere and using a kind of a reactive force jetting out and rotating the sphere. There was no really mechanical work, positive work, so to say, done by this device, but being the first documented one, it shows that people tried in practice to manufacture a device that were able to run on steam. Again, what kind of materials are being used now, sustaining the high temperatures, being able to contain boiled water and to send the steam without leakages into a moving device was a critical issue. Then we come to where our modern age really started. That would be the Industrial Revolution in the 1600s, 1700s, towards the middle of the 20th century. The first big, actually the biggest thermal machine in the old days were those, well, let's call it first phase steam engines. Their purpose was not to produce power really. Their main application was to pump water, to drain water out of mines in most cases. And the first such big engine was used in England, the so-called Thomas Newcomen engine, around year 1700, which was pretty simple. Now imagine, we're talking about 300 years ago, more than 300 years ago, when it was very difficult really to produce a steel cylinder. This was a cast iron sphere operating at atmospheric conditions. It was not even pressurized, not to mention any kind of proper sealing. It was boiling water at more or less atmospheric conditions, atmospheric pressure, which was saturated steam was sent to the cylinder here, the main action piston, where vacuum power was used. So cold water injected by the auxiliary pump into the cylinder, forcing the steam to condense, producing suction or vacuum, which was the main driving force for the pump. These machines actually started the development of many other areas of engineering, and some of those would be, first of all, control systems. Mechanical engineering related to materials, and any other operational issues actually connected to automizing this machine. The very first such machines, they needed manual labor in terms of there was a person sitting somewhere here operating by hand, opening and closing the valves. So it took a while until people actually found out that it is easy and, well, not easy, but possible to link with some kind of levers all those valves. So they operate automatically. They are being opened and closed by the machine itself. They're connected directly to the motion of the main piston. This was the start of automation engineering, actually. Throughout the years, our modern time started with those big steam engines. Everything we have today was initiated by steam power. Steam traction in the old days, locomotives, and later on also ships. Also steam engine driven workshops and factories. Everything was steam driven up until the beginning of the 20th century. Usually in a typical workshop or a factory, a central big steam engine was running all the tools with the help of belt drives or any other kind of arrangements. The first real power plant, now being driven by a steam engine, quite the same as the steam engines in the locomotives, was constructed approximately at the same time in year 1882 by Edison himself in New York and London. It had an efficiency of 6%, electrical efficiency about 6%. Quite the same as for the typical steam locomotive. Starting from this poorly efficient cycle and ending up with modern power plants being more efficient than 40% usually, or even if you use the most or the cheapest possible and simple materials, you would still be above 30% efficient. It took some time and development, and there is a room for continuing this development even further on. In the modern world, approximately 90% of all the electricity being produced today is actually produced by thermal cycles, where a steam cycle or thermal power plants, where the steam cycle is the main driving engine. Regardless of the fuel, it could be a fossil fuel powered plant, it could be a biomass or any renewable fuel fired plant, it could be even nuclear or even fusion nuclear. It still is a steam cycle, especially in large scales, that would be actually converting the energy. From several megawatts, the smallest practical steam units, up to beyond 1,000 megawatt per unit. The fundamental steam cycle, the fundamental concept actually remains exactly the same as 300 years ago. It is very interesting to look at the simple steam boiler, which can be represented by the steam locomotive. These beautiful pieces of engineering from the old days, which were actually the biggest thermal machines ever built by people 100 years ago, and were indeed in practical use until the middle of the 20th century in certain corners of the world, including Europe, they are quite forgotten these days. It is a bit difficult to find the blueprints if you want to renovate a steam locomotive, even if we have quite many of those sitting in museums. They can be regarded as a typical closed vessel type of steam boiler, which is the simplest system you can imagine. Filling in a cylinder with liquid water, not to the top, but allowing a certain vapor cushion at the top position here, sealing it, closing it as good as possible, and then heating it up. What would happen? Well, pressure will build up inside the boiler, which is directly linked to the temperature of the boiler. Now, it producing saturated steam. The conditions inside the water vessel are saturated. Depending on the heating rate, there would be pressure building up inside the cylinder. And a good rule of thumb, that was exactly the pressure at which the most of the old locomotives were operating at, that would be 10 bars, so 10 atmospheres. This means 180 degrees in the water tank. The fireplace is quite simple. It doesn't matter really how it looks like. Air taken in under the grate and through the opening. The machinist here shoving in coal. A common combustion occurs inside the furnace, and the exhaust gases, the hot gases, passing through a range of pipes, pretty similar to the modern fire tube boiler, the so-called fire tube boilers, then being exhausted through a chimney. Water is boiling inside, producing saturated steam, which is drawn from the top and sent in through one of those exhaust gas pipes, attempting a slight superheat. The slightly superheated steam is then transported to the main action cylinder, which can be manufactured in different ways. This example here is like a double action cylinder, taking in the slightly superheated steam on both sides, reciprocating or acting one after the other, and then allowing it to expand and releasing it without condensing, then getting rid of the steam, mixing it with the exhaust gases more or less in the same chimney, and releasing it to the atmosphere without condensation. This means that the working fluid is being lost. It's being used throughout the cycle. So some kind of replenishment or refilling the cylinder is needed. And that's how the locomotives were operating. At the next major station, you stop the train, you fill in the whole cylinder with water, you heat it up again, it may take several hours, and you continue the ride. Leakages, of course, occur everywhere in the system. It was very difficult to run such kind of a piston machine with steam, especially steam that is partly condensing inside. And of course, the arrangement of the piston rod and the whole crankshaft concept was quite simple in the old days, but it was operating quite reliably. The modern steam boiler does not operate as a closed vessel. We can rather regard it as a continuous circulating system. It's a continuous circuit where the working fluid, in the best case, in the ideal case, is not lost. It circulates continuously through the system, and the pump, the feed water pump, is the main component governing the pressure. The pressure in the boiler is controlled completely by the feed water pump. The steam boiler, again, is burning some kind of fuel, doesn't matter what kind it is, transferring heat to the steam, boiling the water, and attempting to superheat the steam as much as possible, sending it continuously to an expansion device. In the modern concept, that would be some kind of a steam turbine, definitely not a piston device, then condensing the steam in the end back into liquid and recycling the fluid. The working fluid is not lost in the best case. While it circulates continuously through the cycle, being evaporated at one end, expanding, thus producing work, and condensing back into liquid in order to be recycled in the other end. This is the end for the first section. We will continue with the thermodynamic properties and the main features of how we represent steam cycles in tables and diagrams, and how exactly they operate in theoretical terms.